In this video, we're going to be looking at um, temperature stresses on concentration versus time graphs and understanding how they appear at the point of stress and how shifts appear on those graphs. Here we're going to look at the effect of a temperature stress on a graph. So we're going to use the Haber process as our equilibrium system. So we have nitrogen plus hydrogen in equilibrium with ammonia. This reaction is exothermic. So on our graph, we have equilibrium has been established. Nitrogen is in pink. You see it's decreased to an equilibrium concentration. Hydrogen is in blue, and it's decreased 3 times as much as nitrogen because of their coefficients. Ammonia is in green, and it's increased by twice the value of that of nitrogen to reach its equilibrium concentration. So I'm going to just put a little dashed line where our stress is. And the first stress that we're going to talk about is an increase in temperature. Temperature changes do not happen instantaneously, and they don't directly affect concentration. So when we change the temperature of an equilibrium system, we won't see any sudden changes in the concentration like we would see if we changed the volume or the concentration. Instead, we'll see just a shift, so an alteration of our equilibrium concentrations to reach a new equilibrium. In this case, because this is an exothermic reaction, when temperature is increased, we will shift away from the energy term towards the reactants. So our concentration of reactants will go up and our concentration of products will go down. So what that's going to look like is just a sudden shift, just a gradual shift away from our product. So our reactants will go up and our product will go down. This is a shift left. And we know that it's a shift left because the concentration of our reactants has increased. So the concentration of the species on the left side of the reaction have increased, and the concentration of our products have decreased. Now that we're at equilibrium again, we can introduce another stress. This time our stress is going to be to decrease the temperature, so to remove kinetic energy from the system. Because this is an exothermic reaction and we're removing energy, our reaction will shift right to replace the energy that we've removed. So we remove energy, we shift towards the energy term. That means that the concentration of our product, ammonia, will go up. Because our reaction is shifting towards ammonia, the concentration of our reactants will go down. This would be a shift right, and we can recognize it as such from the graph because the concentration of our reactants goes down, so everything on the left side of the equation goes down, and the concentration of our products goes up, so everything on the right side of the equation goes up. If we're examining graphs to identify what the stress was, if we see no sudden change in concentration on our graph, that should indicate that it is a temperature-based stress.